Hello all, welcome back to Aislyn Technologies YouTube channel. Today we're gonna see about robust voice recognition system for identifying original and duplicate voice samples. I'll explain the introduction first. The introduction is about advancement in speech recognition to detect and distinguish between original and duplicate voice sample using audio analysis technique like feature extraction with lip rosa and mel frequency, which is called as MFCC, combined with support vector machine algorithm. It improves the reliability and accuracy of voice recognition systems by requiring user to be physically present. It adds a layer of security beyond traditional password. The system is efficient and accurate and more beneficial for voice commands, searches, and accessibility, particularly for users with reading or difficult for writing. Along with this, I'll explain this abstract. This project focuses on improving speech recognition technology by developing a system capable for accurately distinguish between original and duplicate voices within the dataset. Utilized advanced audio analysis and machine learning technique, the system enhances voice classification, reliability, and accuracy. The traditional authentication methods, often based on weak password, are prone to breaches. A voice recognition system addresses these vulnerabilities by requiring physical presence for access, offering a stronger security solution. This approach enhances voice recognition precision while improving accessibility for individuals with regarding and writing difficulties. Along with this, creating more secure and efficient tool for voice-based interactions. Now I will explain the problem statement. So you know now I'll explain the problem statement. So you guys know the need of the project. There is a growing need for voice recognition system capable of effective distinguish between original and duplicate voices within dataset. The challenge affects the reliability of voice-based authentication and commands, especially in large dataset where high precision is crucial. The goal is to develop a system that improves voice classification, accuracy, and addresses the problem of voice duplication, ensuring the accurate distinguish between genuine voice and replicant voice. Replicated voice. Here, our main objective of this project is to create a sophisticated voice recognition system that accurately identifies original and duplicate voices in the dataset by leveraging advanced audio analysis technique and machine learning algorithms. The project aims to enhance the accuracy and reliability of voice classification. The system will also strengthen security by requiring physical presence for access, reducing vulnerabilities tied to traditional password-based authentication methods. And additionally, the project seeks to improve accessibility for individuals with writing and reading difficulties and offering an efficient tool for voice-based interaction. Other keys Other key goal is to optimize the system's performance to handle large datasets efficiently, ensuring both speed and precision. Through the integration of cutting-edge technologies, the project aims to provide a comprehensive, secure, and reliable solution for voice recognition. So I will take this away. Yeah, here's our flow chart. This is a flow chart of our project. First, we will do a main window. This is fully based on GUI. In GUI itself, we have created two buttons. One is for training the dataset, another for testing. First, we will train the dataset with Librosa, MFC, and we are saving the model. And then we are dumping the model to testing side. And we are uploading the data set of audio files which is contained with along with this data set we are going to input after saving model here. We are giving our data set to the model, so it will predict whether the voice is original or duplicate based on the model it was trained. Now I will show you the code. Yeah, this is our main code. Before that, I will show you our data set. This is our data set. Everything consists of one is for duplicate voice and one original voice. It we have taken this. Now I'll show you the code. I'll run this and then I'll explain along with the GUI. So you will have a great knowledge. I'll run this along with the GUI. I will explain the code. So we'll have a better idea, understanding of this. Yeah. This is our GUI. This is our GUI. I'll explain where it was coming. So this is our GUI. You can see this. The second image, nothing but this was the image. And this is test model. We have button here, no test model. That was the button that was showing this. Now this test model button connected with open test model. It will open test model here, and then it will direct to the main loop. It's nothing but it will open the train model here. It open the train model. It will come to this function, and training will happen based on this. Here your training will happen. Here you can see. Here your features will be extracted of your all file paths, what you are giving here. And then here you're loading the function, and these functions will be extracted. Each and every features of the respected voices will be extracted here of every function will come here. And in main function, you'll what in main function your extracted features, no features and labels, you will split into extend xtest y test, and you'll be moving into a standard scalar. Standard scalar is nothing but your features will be scaled to 0 to 1s. That was standard scalar. And you're fitting into transformer, your extend y10. And here you're building the model using SVN. You are building the model using SVN. After this whole process, you are saving the model as both model as SVM model PKL and scalar PKL. The SVM is a model and scalar is the input format. And this is the input prepost format. And then you will print the accuracy and classification of the here will print the accuracy and classification of the what voice you have given. It will be here. And this is the and this is the second GUI. This is a testing function. Here you will dump the model here. Based on this model, you will give any file path of the voice, and you will select the voice here, and look click the class whether it's a duplicate or original voice. It will come here only. Yeah, I already run to this. Now I will show you GUI. Now this is the GUI. I'm testing the model. After testing, we already tested that. So directly test voice is open. Now I will test any voice. It will direct us to a data set. This is our data set. I'm doing this zero duplicate voice. Based on our model, train the model, it will classify whether the voice is duplicate or original. Yeah. The predicted voice is the zero voice is dubbed voice. Yeah. This is based on our model, what we have new Magesh original voice or Magesh original voice. Yeah, you can see this the predictive voice is Magesh original voice. Thank you for watching our iListen Technology YouTube channel. If you have any doubt in this about this project, you can comment in the comment section. And don't forget to like, share, and subscribe. Thank you.